Hello everyone, today I will be explaining 5 technical questions from the CCNA exam. First, let's look at the first question. The first question says about IPv6, specifically the unicast address in IPv6. What exactly is the difference between multicast addresses and unicast addresses? So, as we already know, a multicast address, for example, if I, as a device, let's say I want to send data to multiple devices at the same time, rather than just one specific device, device A, I send out a multicast packet. This is unicast, and this recognition broadcast, this unicast I send. If I want to reach the other side, device B, then the switch will process it by sending it directly to B, right? It won't send it to C or D. This is unicast. So what about multicast? This unicast. Unicast has a characteristic, for example, let's say this host here is connected to 2 devices, 2 routers. Then there are other routers here. So for this unicast address, this anycast address, it can actually be configured on this device or on this device or even on this device. That is in my entire network. Maybe there are more devices over here. In my whole network, essentially, the same address can, in fact, be configured on multiple different devices. The advantage of configuring the same address is that no matter which region you are in, you can access this same address, the same mirror, from the nearest location. So for this question, based on the principle of anycast, we should choose A. Choose A, right? It says that a single IPv6 unicast address only supports a single node, a single interface. But the IPv6 anycast address is different. It can be assigned to multiple nodes. So the correct answer is A. Let's look at the correct answer. Choose A. All right, the second question. This second question is a bit difficult. The second question is a bit challenging, so let me analyze it for you. Mainly, it's this diagram. The diagram isn't described very clearly, so how can everyone figure out what this question means? It first asks us to look at this diagram, and then the question is about this wireless network. Where is this wireless user located? In which area? This zone means area, and in which area will the user encounter a problem called intermittent connectivity? Connection issues, meaning you connect, then after a while it fails, connect again, and after a while it fails, that kind of problem. So we know that in the early 802.11 protocols, there are these 3 channels, 1, 6, and 11. These 3 channels are non-overlapping channels, right? These 3 are not in conflict, and this diagram expresses that. If you look at the slash on the left, this is channel 1, and channel 1 has a slash pointing to the left, right? So this is channel 1. And which other ones are considered channel 1? 7 is also channel 1, and the right-leaning slashes, as you can see, represent channel 6. So 2 is channel 6, 8 is channel 6, and 5 is also channel 6. Now let's look at channel 11, which is shown as a cross-hatched grid. The grid pattern represents channel 11. So channel 11 includes area 3, area 4, and area 6. Now, after we've set and confirmed this channel, let's take another look at the answer. The answer says that between 1 and 2, in the area between 1 and 2, intermittent faults may occur. Let's see if that's the case, because this one refers to channel 1, right? And then 2 refers to channel 6, although they overlap. There is overlap in this area, meaning coverage overlap, but they are not the same channel, so there won't be any issues between them, right? So the answer to this question is incorrect. Now let's look at 2 and 5, area 2 and area 5. Let me change the color. Area 2 and area 5 don't overlap at all. That is, the coverage area of this SSID doesn't overlap. However, they are on the same channel, right? They both use channel 6, but there won't be any issues between them because their coverage areas don't overlap. Right? So this option in the question is also incorrect. Jury. Next, let's look at option C. Areas 3 and 4 have overlapping coverage and both use channel 11. In this case, there will be co-channel interference, so the correct answer should be C. Now, let's look at option D, areas 3 and 6. It's the same here. Area 3 and Area 6 have different frequencies and their coverage areas do not overlap, so this option is also wrong. The correct answer is C. Let's look at the correct answer. Choose C. All right, question 3. Question 3 asks, which WAN topology provides simplicity? Specifically, which type of WAN topology offers simple and reliable availability? First of all, in a wide area network, such as a carrier network or backbone network, where all the devices, for example, there is a border device here, a CE, customer edge, and another border device CE over here. In between, there are many devices responsible for transmission. These are all P devices which only handle forwarding data. The way they are connected to each other can vary. They can be connected in any manner like this. Between these devices, the links are preferably all set as point-to-point links, right? This is to prevent someone from illegally connecting from the side. Point-to-point links provide this kind of protection. This approach is very simple and practical. So for this question, we choose C. Let's look at the correct answer, point-to-point. Okay, question 4. Question 4 is again about the structure of data centers. Let me erase this part first. In data center architectures, there are spine and leaf switches. So the question is, how are these components connected in a data center structure? The first answer says that the leaf switch is connected to a single spine, right? But actually, it's like this. There can be multiple spines, and there are also multiple leaves below. Of course, there are definitely more leaf switches than spine devices. And the way they're connected is like this. In order to improve redundancy, right, it's impossible for them to all connect to just one spine. So option A is incorrect. Option B says that each leaf switch is connected to every spine device, and this option is correct. So for this question, the answer is B. You don't need to look at the other two. Let's look at the correct answer. Choose B. All right, question 5. Question 5 is the one about spanning trees. For spanning trees, it says that in this spanning tree protocol, we've enabled a feature, a function called PortFast, which is a fast interface feature. What is the main purpose of enabling this feature? The main purpose is actually quite obvious. It's to achieve faster convergence, to speed up the convergence process. Because we all know that the spanning tree protocol deployed between switches And then here I connect a host. So this is called, for example, an access switch, right? Then here is the distribution switch. All right, so in this situation, we have enabled the spanning tree protocol in the middle. Now, when this device is connected, first B needs to send a BPDU, and it keeps sending BPDUs. It needs to wait for 30 seconds, and if after 30 seconds the other side hasn't responded or hasn't sent a BPDU, it means this interface is a designated port. So this part requires a 30-second wait. Now, if the uplink goes down, I need to switch to this one, meaning the interface that was originally an alternate port, I need to switch it from an alternate port to a root port. During this process, I need to go through a learning phase for 15 seconds, then learn the forwarding mark. Only after learning the mark can it forward. So 15 seconds for learning, then 15 seconds for listening. Right? This process also takes 30 seconds. Now, if the backbone link goes down, for example, this one is the root, and this one is the secondary, meaning the secondary root, then if the link between the primary root and the secondary root breaks, and this interface wants to come up, in addition to those 30 seconds, it also needs to confirm whether the primary root has actually failed, whether the primary root is really down. That requires another 20 seconds, so this makes the process very slow. Now, when we enable this, where is the purpose function actually used? It's used on the access interface, and it makes the interface not participate in the spanning tree election. By not participating in the spanning tree election, those 30 seconds are eliminated, right? So this question is designed to speed up its convergence. Choose D. Let's look at the correct answer. Choose D. All right, submit. If you want to learn Cisco technologies or get access to the Cisco question bank, please send me a private message, or you can leave a comment below the video for technical discussions.